Hey Summit. So this is going to be a quick description of how you can get your blackout hex set up. So basically you're going to get it, it's going to look similar to this one except without the green stuff, and the props are going to be off. And you're going to want to unscrew all of the 8 screws on the top and just lift and set the top plate to the side. Then inside there you're going to see your flight controller, which is, it's the same as this flight controller, just this is not on the quad. And your flight controller is just going to have this breakout cord here with all these different channel connections. You'll get your receiver. So here I have one of my receivers. It's a FreeSky receiver, and from this this breakout cord I have the channels numbered, and so channel number 1 is the only cord that will have the power and the ground wire. All of the rest of them just have signal. So you'll want to get this channel 1 connection with the power and ground, and look at your receiver and see where the channel 1 connection is, and then you'll want to observe on the side where it shows where the positive, negative, and signal wires go, and make sure that the signal wire goes onto the signal pin. That's very important. So connect up channel 1 and then get channel 2 from the breakout cord. And you can also see here on the board it actually says channel 1, 2, 3, and then on the back 4, 5, 6, 7. So you'll then connect up channel 2, making sure that the signal, there's only one wire on the rest of the pins, but channel 2 goes into number 2, 3 goes into number 3, 4 goes into number 4, 5 goes into number 5, and 6 goes into number 6. Once you have those 6 channels connected to your receiver like this, then you can go ahead and connect up your craft to your computer. So what you'll want to do is, if you use Google Chrome, just go to Google Chrome and search Google Clean Flight, and here I'll show you it. If you Google Clean Flight configurator is the app that you'll want, so you can just install that into Google Chrome. And then what you also need to do is install UART drivers for, and then whatever your operating system is, or you can just Google Clean Flight drivers, and you can see here's a really good blog post about it. And if you just scroll down, then you can see that you need to download the drivers for the Naze board, and here's an address to download the drivers. Once you get that installed, then you can connect it up. So the connection for your board, for where you connect it, is on the side, and so you'll actually, it's kind of a pain, you'll have to get your screwdriver and unscrew this vertical panel, and that will allow you to plug into the board, and it's just a micro USB that you plug into the board. And so I'm going to go ahead and plug mine in now so you can see what it looks like on the computer. Alright, so I've got mine plugged in, and the board flashes, and then it should go to a green and blue light. And you can see now that I can see the quad in the software. And so what we're going to do is actually, to get the to make sure that everything is correct, basically the first thing you'll want to do once you've got it plugged in like this is just click calibrate accelerometer, and this will make sure that it knows what the level surface is. And then you'll go into configuration, and this is very important. My receiver is just using one channel connection, so it's in PPM mode. You'll want to check this RX parallel PWM. That's the receiver mode that you want. That's very important. And also down here, if you have a Spectrum receiver, you can put that in, or if you have an S-Bus or I don't really know how to manage those, so I just leave it alone how it is. And you can click save and reboot here. And then the important thing is you'll want to go over here, and for this it's important that you have your propellers off. I'm not going to be messing around with mine very much, so don't do this at home, but you should take your propellers off for this. If you turn on your radio, and I'm going to select
Stabilize.
the model here, and then if I connect the battery, or a battery, just kind of any 3 or 4 cell battery to the hex.
Low battery. Battery critical.
Oh, that's annoying. There we go. Alright, so now I've connected it up, because basically
Low battery. Battery critical.
the receiver gets power from the flight controller. So to have the receiver turn on, you need to have the flight controller powered by the battery. So now we have the receiver powered, and you can see in here that you can see now the channels are normal. And so we have the throttle, which corresponds to the throttle, and this is where you can reverse any of your different channels if you so want. So over here on the channel map, you can see that I have aileron, elevator, throttle, rudder in the order 1, 2, 3, 4. That's the order that we connected these first 4 channels, going 1, 2, 3, 4. And so what you can do is you can make sure that the pitch, when you push pitch forwards, the pitch increases. When you pull pitch down, the pitch decreases. When you roll right, the roll increases. When you roll left, the roll decreases. When you yaw right, it yaws to the right. And when you yaw left, it yaws to the left. Mine's beeping because that's actually how I arm it. And when you throttle up and down. Now, what we use the channel 5 for in this is channel 5 is for the flight mode. So you can configure one of your switches to control the different flight modes. So I have channel 5 as an auxiliary 1, and you can see that's a 3-position switch for me. So this actually changes my flight modes. And I have another switch as well, which activates a beeper, which is a lost model buzzer. So if I go into flight modes here, you can see that when my auxiliary 1, which is channel 5, is in position 1, it's in horizon mode. When I flip to position 2, it's no longer in horizon mode because that goes red. And then over here, how I get the beeper to work is auxiliary 2, which is channel 6. When in its natural mode, it's not activated, and when I flip it on, then it does activate the beeper. And that's about it. If you do find that in this mode, say when you move your aileron or your roll, say it moves the pitch, so it means that the channel is not in the right order, what you can do is you can remap this. So using a CLI command, you can say map, and then whatever your channel order is, that you can find a lot of good info on this online. And see, like this blog that Oscar Lang has is how to set up the clean flight, and it's a really good setup. You don't need to calibrate the ESCs because that's already done, and I already have some firmware flash to it. And yeah, once you're finished with this, you just disconnect the quad and close this, and then you can power it off and unplug it from your computer. And once you've got it powered off and unplugged from your computer, then you can put the standoff back in and screw the top plate back on, and at this point you should be pretty much ready to go. What I usually do, once more, with the propellers off, once I've configured it like that, you can strap a battery on the top of it and turn on your radio and plug it in, and then you can double check that it is actually working correctly. So you can basically, with it in stabilized mode, you can give it a little bit of throttle and observe if all of the motors speed up correctly, and then if you tilt it forwards, the front motors should speed up faster because they're trying to stabilize it. If you tilt it backwards, the back motors should speed up faster. Left, the left motors should, and right, the right motors should. So that's kind of a way to test it. And then you can put the propellers on, go outside to preferably an open area over grass, and give it a test flight.